Okay, Assalamualaikum. Let's continue on the second part. So the second part is the photolithography. So what is the photolithography? From the name photo. So we're going to pattern the photoresist film by expose to the light. Expose the film to the pattern mask and transfer it the pattern on the mask to the photoresist layer. So you're going to expose your pattern mask to a light. That's why we call it photolithography, to transfer the pattern. So how are we going to do that? So let's say your substrate is a silicon. So in order for you to do photolithography, we need what we call mask. So what is actually mask? So it's actually a glass substrate. We're going to pattern your design on top of your glass substrate. So this pattern is designed using chrome. So we call this one chrome on glass. Chrome mask. So chrome mask usually use the glass substrate. So you need to have this mask because when you're going to transfer the pattern, you need to use the light. So this light, when let's say here we have a design, so the one that is exposed will be transferred or the other way. So this is what this mask is actually the photo is a transfer pattern. So you need to have what we call photoresist material. Okay. So what is actually photoresist? Photoresist is made up of a polymer, that is what we call base resin, and another one we call photoactive component that is light sensitive and a solvent. So if you have experience to do the printed circuit board before, so you have what we call FR4, right? And on top of that you have a copper. So in order for you to design that copper, you need to also go through this photolithography process. But your photoresist is actually a film that is very sensitive to light. So in order for you to expose that film, you need to go to the yellow room. So the process is almost the same with what you need to do with the photolithography. So there are two types of the resist. So in PCB we call this one film, but in your MEMS device resist is in terms of the solution. So we have two types of resist. One is what we call positive resist, another one is called negative resist. So for positive resist, when you expose to the light, so that's why we call photolithography, so it becomes soluble to the developer. So the one that is exposed to the light will become soluble. But for your negative resist, the one that is exposed to light will become hardened. So this is opposite. So photoresist will be the same. The one that is exposed will become soluble. For negative resist, the one that is exposed will become hardened. So let's say this is the design of your mask. So you have two choice. One, you're going to use negative photoresist. Another one, we are going to use positive photoresist. So if you choose for positive photoresist, the one that is exposed will be soluble. So this, where is the part that is exposed, is the white part here, will become soluble. But if you choose for negative photoresist, the one that is exposed will be hardened. So means your design is actually the black one here. It will be opposite. So your positive, the developed resist pattern is identical. So if we see the design here is like a cantilever from the top view. So positive, it will have the same design. But if you choose for negative photoresist, the developed resist pattern will be opposite, will be negative of the mask pattern. So the choice of the positive and negative resist is important for you to make your MEMS device. Okay, just now we saying about the mask, right? So what is actually the mask? Mask is actually from the glass substrate. So you're going to do your design on top. So either use any CAD software such as Cadence, AutoCAD, EDS. So the file need to be in the form of a GDS file. So you're going to draw your design. Let's say I do piezo energy harvester. So this is all your design. You're going to pack inside the chrome mask. So this chrome mask is fabricated outside. So the cost is around like 1,000. So you need to compact all your design at all area because this is quite expensive mask. So this will be what we call photo mask. Okay, so how is the process of the photolithography? Okay, the first one is you need to design your mask. So your mask need to be capable to either positive or negative resist. And second one, after you have designed your mask, this is where the photolithography starts. First, you need to bake your substrate. First, you need to clean your substrate, and then you need to bake your substrate to bake. And sometimes this is optional. Sometimes we do have the adhesion promoter coating, but sometimes we're going to skip these steps. Directly move to the photoresist coating. This is where you're going to choose either you are going to have positive or negative resist. So this coating, the resist will be in terms of the liquid. So you're going to spin coat on top of your substrate, and then you're going to put it on the hot plate to make sure that the resist is coated uniformly. And then this is where the exposure of the lights goes, where you're going to use mask liner to expose the light on the substrate, and the resist will be developed. And after that, how you're going to strip it? You're going to put inside the what we call developer. So it will remove whatever is not exposed for positive resist, or it will be opposite for the negative resist. Okay, so this is how the process works. First, you need to clean your substrate, and then you need to heat your wafer up to 150 or 200 degrees Celsius to remove all the moisture. Let's say you have the acetate or DI moisture on top, to make sure it is very dry. So it can be done either in the oven or the hot plate. Okay, for after a few minutes, and then you're going to put your photoresist. So this is where you choose either you're going to use positive photoresist or negative photoresist. So the photoresist is in terms of a solution, a liquid. You're going to tip your photoresist on top, in the middle, and then this machine what we call spin coater. So your substrate will be spin, and centrifugal spin, and your photoresist will be goes on top of your substrate. So the RPM is around 2000 to 6000. How we know which RPM that we need to use? So it depends on the recipe of the photoresist. After that, after it has been spin coated uniformly, so you're going to put back again on your hot plate to harden your photoresist. Okay, and after that, we're going to put inside the mask liner. So inside the mask liner, where you're going to have your substrate, your mask on top, and this is your substrate. Let's say this is your silicone substrate. This is the photoresist. The blue one here is the photoresist that you already been coated on top. Okay, and then you're going to expose the UV from top and transfer the light from top to the bottom. If let's say you choose positive photoresist, okay, so the one that will expose will be very soluble. This one will be removed if it is positive. But if you choose negative resist, the solution that is negative resist, the one that is unexposed are removed. So which part that is unexposed? This part, and this part will be removed. So it depends on whether you choose positive or negative resist. Okay, so in order to have this design, after you have baked your photoresist, you need to dip inside what we call developer. This is a solution, depends on the type of photoresist. So it will react inside the solution for a few minutes. So means, let's say you choose positive photoresist, the one that is exposed just now, which part that is exposed? This part that is exposed will be removed. So the one that is not exposed will be remain. So if you choose the other way, so this is the final product. Okay. Then after that, you're going to make again, put inside on the hot plate, and it is ready to go. So this is the summary. So the below one is your substrate. This one is your photoresist, where you're going to spin coat it. This is where you put your mask on top. So and then you're going to expose with the UV. If you choose positive resist, the one that is exposed will be removed. If negative resist, the one that is not exposed will be removed. So this concept is important. Okay, and then this is another definition. Okay, if you have multiple layer, so the example just now is only one layer. So let's say you are having a different mask. So let's say the first one you're going to etch one part, the other one you're going to etch another part. So there will be two layer of mask. So in order for you to have two layer of your mask, alignment is very important. Okay, so if you didn't do alignment properly, so your device will be not fabricate properly. So let's say this is mask 1 and mask 2. So when you design your mask, you need to make sure you put what we call alignment marks. So this alignment marks need to be assigned properly using the microscope inside the mask aligner. Okay, so that is a summary of the photolithography process. What is photolithography? Is to transfer the pattern through the light. So whether you choose positive, means the one that is exposed will be removed, or you choose negative, the one that is unexposed will be removed. So for the next video, we will move to the substrate stream, additive, and until the CVD. Assalamualaikum.